You've likely seen the movie Avatar, but even if you haven't, don't worry. Today, I'm going to walk you through everything you need to know about its fascinating world. In the film, we are introduced to a world called Pandora. It was so stunningly beautiful that it captured the imagination of the entire world. Pandora featured glowing jungles that emitted a bioluminescent blue light at night and massive Hallelujah mountains that floated in the sky without any physical support. The inhabitants of this world are the Na'vi, a race of blue-skinned aliens standing 10 feet tall. Perhaps the most intriguing part is their ability to connect their tails to trees and animals, much like we connect a phone to Wi-Fi. When I first saw this, a question struck me. Is there actually a place in our universe where such life could exist? Are there aliens living out there right now that we haven't discovered? Today, we will explore what scientists have found and whether a place like Pandora could truly exist in our universe. Where is Pandora? First, let's understand what Pandora was. In the movie, Pandora isn't a planet. It's a moon orbiting a gas giant named Polyphemus. This system orbits a star called Alpha Centauri. The most exciting part? Alpha Centauri is a real star system. It is the closest neighbor to our solar system, located just 4.37 light years away. Now, what does 4.37 light years mean? Light travels at about 300,000 kilometers per second. At that speed, you could circle the Earth 7 times in just 1 second. 1 light year is the distance light travels in a year, which is roughly 9.5 trillion kilometers. So, Alpha Centauri is about 40 trillion kilometers away. If we used our current fastest spacecraft, it would take us 70,000 years to get there. While that sounds like an eternity, in the grand scale of the universe, it's actually right next door. Could a Pandora exist there? In 2016, scientists made a massive discovery, a planet named Proxima Centauri b in the Alpha Centauri system. It is Earth-sized and sits at the perfect distance from its star, not too hot, not too cold. Scientists call this the habitable zone, or the Goldilocks zone. Think of it like a room heater. If you sit too close, you burn. Too far, and you freeze. There is a perfect spot in the middle. If a planet sits in this zone, water can remain in liquid form. And where there is water, there is a possibility for life. Earth's big brother, Kepler 452b. In 2015, another planet made headlines, Kepler 452b. Scientists were shocked by how much it resembled Earth. It orbits a star very similar to our Sun, and its year is 385 days, strikingly close to our 365 days. However, there are big differences. Kepler 452b is 60% larger than Earth, and its gravity is twice as strong. If you weigh 50 kilograms on Earth, you'd feel like 100 kilograms there. Walking would be an exhausting struggle. While it's in the habitable zone, we can't confirm life there yet because it is 1,400 light years away. How do we search from so far away? Since we can't travel there yet, we use spectroscopy. When light from a star passes through a planet's atmosphere, the gases in that air change the light slightly. By studying these changes, scientists can identify gases like oxygen or methane. On Earth, these gases are largely produced by life, so finding them elsewhere would be a smoking gun for alien existence. The TRAPPIST-1 system. In 2017, we found the TRAPPIST-1 system, located 40 light-years away. It has 7 Earth-sized planets, 3 of which are in the habitable zone. These planets are so close to each other that if you stood on one, you could see the others in the sky as clearly as we see our moon. Shutterstock. Explore. What would aliens actually look like? If life exists there, would they look like the Na'vi? Scientists suggest alien life might be more alien than we imagine. Earth life is carbon-based, but elsewhere, life could be silicon-based. They might look so different, we wouldn't even recognize them as alive. Gravity also dictates appearance. On a high-gravity planet, creatures would likely be short and sturdy, to support their weight. On low-gravity worlds, they might be tall and spindly. Even the color of the star matters. If a star is a red dwarf, planets might be red or black to better absorb the light. Floating mountains and glowing plants. In Avatar, the unobtainium mineral allowed mountains to float via magnetic fields. While we haven't found that, we do have superconductors. At extremely cold temperatures, these can repel magnetic fields and levitate. However, achieving those temperatures naturally on a planet is unlikely. As for glowing jungles, that is very real. It's called bioluminescence. We see it on Earth in jellyfish, certain fish, and even glowing mushrooms. If a planet is perpetually dark or has long nights, life there would likely evolve to glow. How will we get there? Current tech takes 70,000 years, but new ideas are emerging. Breakthrough. Starshot. This project aims to use powerful lasers to push tiny postage stamp-sized probes to 20% the speed of light, reaching Alpha Centauris in just 20 years. Wormholes, a theoretical shortcut through space. Imagine folding a piece of paper to bring two distant points together. While a staple of sci-fi, we don't know if they truly exist. The Fermi Paradox. Where is everybody? If there are billions of planets, why haven't we heard from anyone? This is the Fermi Paradox. Maybe they are so advanced they view us like ants, not worth talking to. Maybe they are hiding from a universal threat. Maybe life is just incredibly rare. The most likely reason? The universe is too big, and we've only just started looking. Our galaxy alone has over 100 billion planets. We've only checked a tiny fraction. A warning and a realization. Some, like Stephen Hawking, warned that meeting advanced aliens could be dangerous. Historically, when an advanced civilization meets a less advanced one, like Europeans arriving in the Americas, it rarely ends well for the latter. Ultimately, studying the stars makes us realize how perfect Earth is. We have the right sun, the right distance, a moon that stabilizes our tilt, Jupiter to deflect asteroids, and a magnetic field to block radiation. If any of these were slightly off, we wouldn't be here. Final verdict. While an exact Pandora might be a movie fantasy, planets capable of supporting strange and beautiful life almost certainly exist. As our technology evolves, we may finally find them. What do you think? Are we alone in this vast cosmic ocean? Or are the neighbors just waiting for us to get smarter?